Hi, and welcome back to the FE exam review series where we focus on problems built around core fundamentals that will help you pass your FE exam. Today's problem is based off of subsection D, linear algebra, under the mathematics subject. You can try the problem for yourself using the first link in the description below. The only way to refresh these concepts is to practice, and you have to try it yourself. So please go ahead and try the problem. I'm going to get into the solution now. We're given a 3 by 3 matrix above, and we're asked to find the determinant. Now, definitely the easiest way to do a problem like this would be on your calculator. You could input the matrix and find the determinant. But let's say you don't have a calculator. I'm going to give you guys a tip here that's going to make this problem a one-liner. Before we do that, we're going to review how we exactly take the determinant, and starting with the 3 by 3 matrix, you really have to understand how to take the determinant of a 2 by 2 matrix because it's just that process repeated. Now, if we have the 2 by 2 matrix, for instance, like 1, 2, 3, 4, and we wanted to find the determinant, it's kind of a cross multiplication process with a negative sign in the center. You have a 1 times 4 minus a 2 times 3, and that will be the determinant of the matrix 1, 2, 3, 4. That's 4 minus 6 is a negative 2. Now that's the determinant of a 2 by 2 matrix. And finding the determinant of a 3 by 3 matrix is a similar process, except it's repeated a few times, and these determinants gain a sign. That sign determinant is referred to as a cofactor. So let's say we're expanding on the first row, for instance. As we expand on the first row, we write down the terms associated with the first row, 4, 0, and negative 2. And our goal now is to find these kind of signed mini determinants that we apply to these factors that we just wrote down for the first row. And these sign determinants, again, they're called cofactors. The sign associated with the first one is found by looking at that kind of checkerboard pattern on the bottom that you see. And you can cross out the first row, first column, and you see we isolate a set of 4 numbers, negative 1, 5, 0, 1, and that's our cofactor that we have associated with the first element. For the second element, it's a 0. So that means that we don't really have to find this cofactor because 0 times anything is going to be 0. But just for practice purposes, we're going to go ahead and find the cofactor associated with that one. Crossing off the first row second element, what we see is we isolate these set of numbers, 3, 5, 2, and 1. And there is a negative sign associated with that. So we're going to put a minus right here, multiply that by minus 1. And for the third element, the first row, third column, we isolate these set of numbers, 3, negative 1, 2, 0, and there is a positive sign associated with that. So we multiply that by positive 1, it'll be unchanged. Now, we could compute the determinant like this, but you can do this problem faster, a lot faster, if you realize that you can expand the determinant by any row or column that you choose. So it's advantageous to pick a row or column with a lot of zeros, like the second column, for instance. The second column, you just have the minus 1 term, so that means you only have to find a single cofactor, which is 4, negative 2, 2, 1. And the sign associated with that is a positive sign, so we don't change this. And this is equivalently the determinant of matrix A. So that will be negative 1 multiplied by 4 minus a negative 4. That's a positive 8 times negative 1. It's a negative 8 as the solution. So that would be our answer. Let's go ahead and check that answer, make sure that it's correct, and we can quickly kind of review what we did. We basically said that without the calculator, the fastest way to do this would be to look for the row or column with the maximum number of zeros. We see that column 2 has the most zeros here, so it's easiest to expand. We take that negative 1 factor and we multiply it by its associated cofactor, which was this little mini matrix here. And the sign associated with that was a positive sign. And yeah, we got a determinant of negative 8. If you enjoyed the video, you learned something from the video, Consider leaving a like and subscribing for more content like this. Additionally, if you're preparing for the FE mechanical exam, you can check out my software, FE Interactive. That's where all these problems are coming from, and that's this interface here. Thanks for watching. I'll see you in the next video. Goodbye.